Welcome back. We're here to break down complex physics concepts into simple, easy to understand lessons. Today, we're covering a fundamental concept that's essential for understanding projectile motion, forces, and more: vector addition and unit vectors. By the end of this video, you'll know how to represent vectors, break them into components, and add them both graphically and algebraically. Let's jump in. First off, what is a vector? A vector is a quantity that has both magnitude and direction. That means it's not just a number, it also points somewhere. Common examples of vectors include velocity, displacement, acceleration, and force. Say a car moves 10 meters to the right. That's a displacement vector. Or, if you're pushing a box with 5 newtons of force at a 30-degree angle above the horizontal, that's a force vector. Scalars, on the other hand, are quantities with only magnitude, like mass, time, or temperature. But we'll be working with vectors today. To analyze vectors, we usually place them on a Cartesian coordinate system, a simple x and y grid. A vector can be described in two ways: magnitude and direction, like 5 meters at 30 degrees. Or, in terms of components, how far it goes in the x direction and y direction. And this is where unit vectors come in. In physics, we use unit vectors to break any vector into its x and y components. The unit vector I hat points along the x-axis. The unit vector j hat points along the y-axis. Let's say you have a vector A that points up and to the right. It makes an angle theta with the x-axis and has a magnitude of A. We can find its components using A sub x equals A times cosine theta, A sub y equals A times sine theta. Now we can write the vector in unit vector form. Vector A equals A sub x times I hat, plus A sub I times j hat. Let's do an example. Suppose A equals 10 meters, and the angle is 60 degrees. Then, A sub x equals 10 times cosine 60, which equals 5. A sub y equals 10 times sine 60, which equals 8.66. So, the vector becomes A equals 5, I hat plus 8.66 j hat. Suppose you walk 4 meters east, then 3 meters north. These are two vectors. Vector A is 4 meters east. Vector B is 3 meters north. To add vectors graphically, we use the head-to-tail method. First, draw vector A. Then, place vector B starting at the tip of vector A. The resultant vector goes from the starting point of A to the end of B. To find the length of the resultant, we use the Pythagorean theorem. R equals the square root of A squared plus B squared. That's 4 squared plus 3 squared, which gives us R equals 5 meters. To find the direction of the resultant, use the inverse tangent of B over A. That's 3 divided by 4. So, theta equals inverse tangent of 3/4, which is approximately 36.87 degrees. Resultant, 5 meters at 36.87 degrees north of east. We can also add vectors algebraically using their components. Let's say vector A equals 3 I hat plus 2 j hat. Vector B equals 1 I hat plus 4 j hat. To add them, we simply add the x components and the y components. So the resultant vector R is 3 plus 1 I hat plus 2 plus 4 j hat. That gives us R equals 4 I hat plus 6 j hat. Now to find the magnitude of R, take the square root of 4 squared plus 6 squared. That's 16 plus 36, which equals 52. So the magnitude is about 7.21. To find the angle, use inverse tangent of y over x. Theta equals inverse tangent of 6 divided by 4, which is inverse tangent of 1.5, and that's approximately 56.31 degrees. This method works even when your vectors point in different directions and you're not drawing them. So let's review. Vectors have magnitude and direction. We can represent vectors using components and unit vectors. To add vectors, we use either the head-to-tail method or the component method. Mastering these basics is crucial for understanding more advanced topics like projectile motion, forces at angles, and circular motion. In our next video, we'll apply all of this to projectiles: how they fly, how long they stay in the air, and how far they travel. If this video helped you, give it a thumbs up, subscribe, and drop a comment if you have any questions. See you next time.